Physics Semester 2 Final Review. Name? What's my name? Number 1. When Harry got his butt kicked by Malfoy... wrote this. In a duel during his second year...
Take this, Potter! Averte statum!
What was his momentum after getting hit with the Avarte Statum spell if his mass is 60 kilograms and his velocity is 15 meters per second? It's not happening. Hedwig.
Hedwig? Like a wig on your head? Classic.
Let's ask Hermione. She's a nerd. Hermione, what do?
Hello, Hedwig. You haven't even started? I've literally been done for 3 weeks.
Please.
Fine. Which problem?
Thank you. Number 1. Seventh-year students are exempt from WODs. Wizard on demands. Oh, Hedwig.
Problem 1 is a basic momentum problem. In this, use the equation P equals mass times the change in velocity. The mass and velocity are given, with the change in velocity being 15 meters per second and the mass being 60 kilograms. You find the momentum by multiplying these numbers together.
Dean, 65 kilograms, is flying on his broom at 12 meters per second when Dean 2, also 65 kilograms, throws a bludger at 16 meters per second at him. The bludger bounces off at a velocity of 10 meters per second.
Ow!
What is Dean's final velocity? Part B. Dean is flying on his broom at 12 meters per second when Dean 2 throws a quaffle at him at 5 meters per second. Dean catches it and flies off. What is their combined final velocity?
A few moments later.
I can't do it. I'm just gonna pull a little wizard skip on this problem. No, I have to do this. Ooh, I know. About this number 2 problem. Fly.
Are you going to do this for every single question? Problem 2 is elastic and inelastic collisions. Part A deals with elastic collisions because the bludger bounces off. The formula that you're going to use is mass 1 times the velocity initial of the first object plus mass 2 times the initial velocity of the second object equals mass 1 times the final velocity of the first object plus mass 2 times the final velocity of the second object. The first mass is Dean's mass times his velocity, plus the mass of the bludger times its velocity equals Dean's mass times his new velocity, which is what we're trying to find, plus the bludger's mass times its new velocity. Part B deals with inelastic collisions because Dean catches the quaffle. The equation that we're going to use is mass 1 times the initial velocity of the first object plus mass 2 times the initial velocity of the second object equals mass 1 plus mass 2 times their final velocity. The first mass that we're going to use is Dean's mass, 65 kilograms times his velocity, 12 meters per second, plus the 2 kilogram mass of the quaffle times its velocity, 5 meters per second, equals their combined mass times their final velocity, which is what we're trying to find.
Nice, we did it. Oh, God. Let's, yeah, send this over to Hermione. Yeah, you might as well just, knock out the other 2 while you're at it. The, Alloto Momentum and the orange problem.
Get wrecked, Voldemort. Fine, here you go. And it's momentum, not momentum.
I got my spell book for the long way round. I was a wizard for the way. And I oh. Momentum, whatever. Still send me the answers. Dean is chasing after Dean 2, was running at a velocity 5 meters per second when he cast the Alloto Momentum spell over 0.5 seconds, slow him down to 0.4 meters per second.
Alloto Momentum!
What is the force caused by this spell?
Problem 3 deals with impulse, which is the change in momentum or the force over time. In this problem, you set force times the change in time equal to mass times the change in velocity. Force, which is what we're trying to find, times the time it took to cast a spell, equals Dean's mass, 65 kilograms, times the change in velocity, 4.96 meters per second.
Now, Dean 2, so physics worksheets have a plot now. Dean 2 is chasing after Dean, who is running at 5 meters per second, and he casts the Transforme Citronius spell, is that a real thing? Turning him into an orange that weighs 0.1 kilograms.
Dang, son, your breath smells like Dobby socks, bro.
Don't make fun of me. I'm gonna cast a new spell on you. Transform into Cronus.
What is his final velocity as an orange?
Problem 4 shows the conservation of momentum. In doing this, we set the mass of the first object times the velocity of the first object equal to the mass of the second object times its velocity. The first mass is Dean's mass, 65 kilograms, times his velocity, which is 5 meters per second. The second mass is the mass of the orange, or 0.1 kilograms, times its velocity, which we are trying to find.
The next day.